Hello and welcome to this clip having a look at the effects of errors on the titer size in a titration. It's in the form of a multiple choice question. So the first part is the description of the titration, which we have just a minute to think about. So I've cut the specific part of the question that talks about what happens in the titration so we can visualize it. So if we take a typical setup, the hydrochloric acid will go in the burette, and the 25 centimeters cube sodium hydroxide solution will go in a conical flask. So here's the whole question, and what they ask you to think about is reasons why a smaller titer occurs with one of the students. And there's 4 different procedures, one of which will actually explain this difference. So what does a smaller titer mean? Well, it means that they've got less hydrochloric acid that reacts. So the burette readings are taken from the top of the meniscus instead of the bottom of the meniscus. Now, the thing to remember about a titration is it's a measurement by difference. So if you take 2 measurements in an equally wrong way, the difference between them won't be affected. Let me try and explain. If we look up close to some liquid in a burette, you've got the top of the meniscus and the bottom of the meniscus. If you read from the top of the meniscus, your reading is incorrect. But the other reading you take once you've emptied some liquid out will be incorrect by the same amount because the meniscus does not change size. So therefore, there's no change to the titer. So it's not this particular option. The next option is the conical flask is rinsed with water before carrying out the titration. So going back to our diagram, we imagine that the conical flask at the bottom has been rinsed with some water, and that means there's a bit of water in the inside of the flask. You now add your next amount of sodium hydroxide, 25 centimeters cubed. If it's the same solution, it'll be the same concentration, so the same number of moles. Water does not react with sodium hydroxide, so there's no change to the number of moles of sodium hydroxide available to react with the incoming acid from the burette. So there'll be no change to the titer here either, but for a different reason. Now let's look at what an air bubble means. Now, an air bubble is released from the jet of the burette. If you have an air bubble, as you empty the burette, that air bubble is pushed out. Now what that means is the air bubble will make the height of liquid in the burette appear a little bit more. In the first reading, you empty the burette a bit, the liquid comes out, takes the air bubble with it. The air bubble doesn't affect the second reading. So what this means is that the perceived amount that's read off in the first reading is a bit bigger. But once the jet has been ejected during the emptying of the titer, the air is no longer there. That little bubble is gone. So only one reading is perceived as greater. The titer calculated will be a greater difference, so therefore it'll be larger. We want something that's going to affect a smaller titer. Now, so far, none of these answers are correct. It's obviously going to be part D, but let's think about why. If we rinse the pipette with water, what that's going to mean is a bit of water is left behind on the inside of the glass of the pipette. What that's going to do when you put some NaOH in there is it's going to have a diluting effect, meaning that when you get to the mark, the 25 centimeters cube mark, there's less moles of sodium hydroxide in there than there would have been if you hadn't rinsed it with water. So therefore, less HCl will be needed to neutralize it, which will make the titer smaller. So that's why it's part D, or option D. Okay, hopefully this has been a useful look at some of the things that affect the size of a titer. Thanks for listening. Until next time, see you soon.